All right, you guys, we're going to learn about some nifty properties of circles when angles intersect inside the circle and outside the circle and on the circle. So, we're going to learn about different angle relationships in circles. Sounds like fun, right? I know. All right, let's keep going, you guys. So, the first type of angle properties we're going to talk about are when angles are created by a tangent line and a secant line. Okay, so the measure of an angle that's formed by a tangent line and a secant line is half the measure of its intercepted arc. So you're probably like, Miss Long, that was a mouthful. What does all that mean? Well, I will explain. Don't you worry, my needy students. I can help you out. But anyways, all right, so here I have a secant. Why is this ray right here a secant? Because it does intersect it 2 times. Okay, so since it intercepts the circle 2 times, that means it's a secant. Okay, and then this ray right here, that is a tangent. Why is ray BC a tangent? Because it intercepts the circle in exactly one spot. So we have a tangent and we have a secant and a tangent that are intersecting the circle. And there's a nifty property about the angle created by the secant and tangent and its intercepted arc, which intercepted arcs, you guys, are arcs that are kind of like within the angle, like arc AB is an intercepted arc because it goes inside of the angle. So that's where it intercepts it. All right, so we're going to do the outer arc. Okay, so if we know, let's go back up to here actually. Okay, so the measure of the angle formed, so the measure of this angle is going to be half the measure of its intercepted arc. So the measure of angle ABC is going to be half the measure of the intercepted arc, which in this case is arc A to the B. Or we could reverse that statement. We know that the measure of the arc, the way that we get the arc is if we know the angle, we're going to double the angle to get the intercepted arc. So if you know the intercepted arc, you half that bad boy to get the angle. And if you know the angle, you double that bad boy to get the measure of the intercepted arc. Okay, so that is the first property we're going to be applying. So go ahead and pause the video and watch example 1. Oh man, example 1 was so much fun, but now we're going to have even more fun by doing some funsies, but you'll have to wait on those. Okay, so now we're going to learn about angles created by 2 chords or 2 secants that intersect inside the circle. Later on, we're going to talk about when things will intersect outside the circle, but hold your horses. We'll get there in a moment. Alrighty, so as you see here in this circle, I have 2 chords that intercept it on the inside of the circle. You could also have 2 secants. Now, the reason why these are chords are because the segments endpoints are on the circle. They start and end on the circle, so it's a chord. Okay, technically, if the chords were continuously to extend, they would be a line, which means they're a secant. So they could be 2 lines going through the circle, okay, which means it's a secant because secants have to intersect the circle in 2 spots. Okay, or it could just simply be a chord like I have over here. So this property states that the measure of an angle formed by 2 secants or chords that intersect inside of the circle is half the measure of the sum of the 2 intercepted arcs. So again, that's a lot to take in, so let's break it down. Okay, so my 2 chords are BD and EC, okay, which BD and EC actually have a lot of arcs that intercept it. So you're probably like, Miss Long, how do I know which arcs to use when I do the problem? Well, I want to tell you. Okay, so in the first case, let's look at angle BAE. Okay, we're going to look at the intercepted arcs that are to the left of it and to the right of it. Okay, so if we have one of the angles formed by the chords or secants that are to the left or right, we'll be looking at the intercepted arcs that are also to the left and right. Snazzy, right? Okay, so if we apply that property, okay, the measure of angle BAE is 1/2 the sums of the arcs that are to the left and to the right of it. So if you add those 2 together and divide by 2, bam, you'll get angle BAE. Similarly, with the other angle to the right this time, so if I look at angle CAD, the 2 intercepted arcs I'm going to be looking at are the arcs that are to the left and to the right of it. So again, if I add up the 2 intercepted arcs and divide by 2, I will get angle CAD. So that applies to either of these 2 angles right here. Okay, now let's talk about the angles that are on top and on bottom. So this angle is like facing up If you have an angle facing up or down, so angle like BAC or EAD, the intercepted arcs that you reference in this case are the arcs that are above it and below it. So if we're to the left or to the right, we look at the intercepted arcs that are to the left or to the right. If we are up or down with our angles, we look to the intercepted arcs that are up or down. So that's kind of the idea behind it. Guys, so the measure of angle BAC will be 1/2 of its two intercepted arcs, which are BC and ED, as well as the other angle that now faces down. We're going to look at the intercepted arcs that go up and down, which again are BC and ED. So we just add up the intercepted arcs and divide by 2. And that's how you get an angle that is created by two chords or two secants that intersect inside the circle. Cool beans. Alright, so go ahead and pause the video and learn how to apply this property in example 2 and 3. Oh man, you guys thought we were done. We're not done because we're about to do a funzie on it, but also there's one more property we need to talk about. So this time we're going to talk about angles that are created by secant and tangent lines intersecting outside of the circle this time. Before, they were intersecting inside the circle. Now they're going to be intersecting outside the circle, so be careful. Okay, so the measure of an angle formed by a secant and tangent line, or formed by secant and tangent lines that intersect outside of a circle is half the measure of the difference of the two intercepted arcs. Whoa, that sounds awfully similar to the last one. Okay, instead of the last one that said it was the sum, if you think back, let's go back. This one said the sum, see this word sum, of the two intercepted arcs. So the last one we half the sum, now we're going to be halving the difference. Okay, so be careful. Okay, so in this first example, I have a tangent ray, which is ray BC, and I have a secant, which is BA, ray BA, because the tangent line hits the circle in exactly one point, point C, and the secant intersects the circle in exactly 2 points, points A and D. So we have a tangent line and a secant. So again, the measure of the angle outside the circle created by this secant and tangent line equals 1/2, and that's supposed to be, sorry, it keeps doing that. See, now it's working. Alright, so, see when I zoom out, that arc flattens out and it bothers me. Why? Watch. When I zoom in, it arcs up. When I zoom out, it flattens out. Oh well. That's supposed to be an arc. I don't know why Prezi is doing that. Probably the demon cats are getting it, so you guys better watch out. But anyways, the measure of the angle outside the circle, is equal to half the measure of the two intercepted arcs subtracted from each other. When I say subtracted, or the difference, we're going to be subtracting the outer intercepted arc, which is the arc furthest away from our outside angle that it intercepts. Okay, and then we're going to subtract the inner intercepted arc. That's complicated to say. Try saying that 5 times fast. Okay, so we're going to subtract the outer intercepted arc minus the inner intercepted arc, and then we'll divide by 2, and that will give us the measure of that exterior angle. Okay, so like in this case, we do the measure of arc DEC minus the measure of arc AC, and then divide by 2. So we do the outer arc minus the inner intercepted arc, and divide by 2. The same is true with 2 more cases. So you can have 2 secants intersecting outside the circle, okay, which these 2 secants are secants BE and BD, so rays BE and BD. Okay, so again, I'm going to half the difference of the intercepted arcs. So the 2 arcs that are inside of this lovely angle are arcs DE and AC. So we're going to start with the arc furthest away from angle B, which is DE, and I'm going to subtract it to the intercepted arc that's closer to it, so the inner intercepted arc, which in this case is AC. So if you subtract those two and divide by 2, bam, we'll get that angle. And the outer arc minus inner arc. Outer arc minus inner arc. Don't forget that. All right, and the last case is if you have 2 tangents, which I know these are tangents because these rays hit the circle in exactly 1 point. Whoa. This one intercepts in point A. This one intercepts in point B. But again, the same thing, you guys. The measure of the angle outside the circle created by these two tangent rays is half the difference of the intercepted arc, which guess what, you guys? I bet if I zoom in again, that will not be... See, it's an arc right here, but when I zoom out, it flattens out, but it's okay. Demon cats, we're gonna get into it in a little bit, don't you worry. But anyways, so it's gonna be the outer arc, which is arc AAC, minus the inner arc, which is AC, and then I'm going to divide that bad boy by 2, and bam, that'll give me the outer angle created by these two tangent lines, or tangent rays, technically. So that would be angle B. Okay, so all three of these circles look slightly different, but they all follow the same formula. So you got to be on the lookout for any of these three cases, and if you spot any of these cases, guess what? The easy thing to know is they use the same formula. So go ahead and pause the video and watch example 4, 5, and 6 and see if you can apply these properties that we just learned about. Nice job, you guys. All right, the final example of the day. We technically won't be combining all the properties. My title is a little misleading. We're just going to be combining more than one property, which the more properties, the more exciting. So this is going to be super duper exciting, so get excited. Lots of exciting. Sorry, guys. I'm not being very creative with my vocabulary today. But anyways, so example 7, you're going to use this nifty picture to find the measure of arc DE and EG. And you're going to be using more than one of the properties we have talked about in this Prezi to help you find the measure of these two arcs. And the funsy we'll be doing later on. Alright, guys, so go ahead and pause the video and watch example 7. Whoa, those are all so much fun. Now you guys will be looking forward to how to find segment links with secant chords and tangent lines that intersect in and outside of a circle. Get ready for the next unit. I hope you guys enjoyed it as much as I did.